My dear students of class 12, welcome to our today's class. I am MD Asghar Khan, Senior Lecturer, Department of Mathematics. How are you? I hope by the grace of Almighty Allah, all of you are well. I am also fine. In previous class, already we have discussed about some mathematical problem of exercise 9D. Today, I will teach you about the example 3 of 9D. If h and h1 the greatest height in the two paths of projectile, then show that r is equal to 4 root over h and h1. Just if you throw a object from this point, you have two paths of projectile. First one is h, second one is h1. They are same line, same horizontal range. So if one angle is alpha for h, for the h, the initial velocity is u, and so first projected angle alpha, so greatest height h is equal to this, because initial velocity for both path is u. So h is equal to u square sin square alpha divided by 2z. This is our greatest height, and horizontal range r is equal to u square sin 2 alpha divided by z. Okay. Now for same horizontal range, second angle be 90 degree minus alpha. If one angle is alpha, because total vertical plane xy plane is 90 degree. If one angle is alpha, then another angle you can use 90 degree minus alpha. Okay, so 90 degree minus alpha. Okay, for greatest height, for this path, greatest height, this projected angle is 90 degree minus alpha, and projected greatest height is h1. So h1 is equal to initial velocity is same, u square sin square 90 degree minus alpha divided by 2 g. Okay, by the trigonometrical identity, trigonometrical concept, 90 degree minus alpha, it will be cos square alpha divided by 2z. Okay, so we want to show this statement. So this is h1 is equal to u square cos square alpha divided by 2z. This is equation number 3. For this expression we need to multiply with 1 and 3. Okay, multiply equation 1 and 3. Equation 1 multiply and equation 3. So h1 is equal to this. We can write it u to the power 4 sin square alpha into cos square alpha divided by 4 g square. Okay, so we need multiply by numerator and denominator by 4. So u4 divided into 4 sin square alpha cos square alpha divided by 16 g square. So u4, we can write it u4, the square of u4 is equal to u square, and 2 sin alpha cos alpha whole square divided by 16 g square. We need to apply this formula. Now u square sin 2 alpha, we can write it 2 sin alpha cos alpha sin 2 alpha whole square divided by 16 g square. Okay. Now 1 by 16, this value is h1, 1 by 16 u square sin 2 alpha divided by g square. Okay, 1 by 16 is equal to u square sin 2 alpha divided by g whole square. Okay, so 1 by 16 u square sin 2 alpha divided by g is equal to r square. So r square divided by 16, this is our value of h and h1. Okay, now h1 r square is equal to 16h h1. So r is equal to root over 16h h1 and root over 16 is equal to 4. So root over h into h1, this is the horizontal range r. This is our proved. Okay. Now example 6, it's a creative question. Example 6, 1. First information is after a stone is dropped downwards at a distance x meter from the top of the wall, another stone is falling from a point at a distance of y meter below from the top. Okay, second information is if a ball is thrown, then it just to clear a wall of a height at a distance b. Okay, question number A bullet loses half of its velocity after penetrating 2 inches inside the wall. How far further will be it more penetrate? This question is same as A number question, same as 9b, exercise 9b, question number 9. Okay, already we have discussed in exercise 9b and question number 9. Okay. Question B is for 1, if the both are falling from the wrist and reach to the ground at the same time, then show that the height of wall is x plus y whole square divided by 4x meter. First information, after a stone dropped downwards at a distance x meter from the top of the wall, another stone is falling from a point at a distance of y meter below from the top, then we have to prove both stone reach the same time at ground, then the height of wall is this, then we have to prove this. Now question B, so after a stone is dropped downward, just think from the figure you can analyze your question by this figure. Just first stone dropped from the point A and this stone reached at a point D on ground. Just After x distance, it reaches at a point B, and when it reaches at a point B, then another stone dropped from the point C, and both are reaches at the same time T at a point D on the ground. Okay, so second stone dropped from C, where height from the top is y. The traveling distance for the second stone is h minus y time is t, and first stone is traveling distance is total traveling distance is ad, and first distance is x, second distance is h minus x, but this distance and this distance for the equal time t, because both stone reaches the ground at same time. Okay, so the height of the wall be h. Okay, now for AB distance we can write, this is a description of this figure. For AB we can apply this formula, b square is equal to u square plus 2gx, and both stone drop from the rest position, so initial velocity is 0, and b is equal to, at a point B the velocity is b, final velocity is b, so b is equal to this. And for BD initial velocity is v, so h minus x is equal to ut, u is replaced by v, bt plus half of gt square, so h minus x is equal to b is equal to root over 2g xt plus half of gt square. This is equation 1. This is the moving distance for the first stone. Now second stone, the moving distance is cd. Okay, for distance cd, h minus y, and drop from the rest position, so h minus y distance, h minus y ut plus half of gt square, h minus y u is equal to 0, then half of gt square. This is equation number 2. Now subtracting equation 1 and 2, then we get from 1 minus 2 we get h minus x minus h plus y is equal to root over 2gx into t plus half of gt square minus half of gt square. So minus x plus y is equal to 2gx into t, so t is equal to y minus x divided by root over 2gx. This is our value of t. Okay, now the value of t we want to replace in equation 2, then we get from 2, okay, h minus y half of g t is equal to y minus x divided by 2gx. Okay, h minus y, then half of g t is equal to this square. Okay, now we want to find the value of h. Half of g into y minus x whole square divided by 2gx. Okay, g and g will be discarded, and y h minus y is equal to 4x y minus x whole square. Okay, now from this we get h is equal to y minus x whole square divided by 4x plus y. Then h is equal to 4x y minus x whole square plus 4xy. Then y square minus 2xy plus x square plus 4xy divided by 4x. Okay, so x square minus 2xy plus 4x, it will be 2xy plus y square divided by 4x. From the numerator we can write x plus y whole square divided by 4x. This is the height of wall. This is our proved. Okay, now question number C. Okay, question number C. If a ball is thrown, then it just to clear a wall of a height at a distance b. First, from the stem, first question, if the ball is thrown, then if the height of wall is a, then it over the height, the ball passing over the height, then a, the height of wall, first wall is a, and for height a, then the distance, the horizontal distance is b. If the height of the wall is b, this is from the question C, and this is the from the question from stem, question stem, and this is from the question C. If the height is b, then horizontal distance is a, and for two case horizontal range is r, and we have to prove this. Okay, so their initial velocity is u, projected angle is alpha for both case, for the both wall, height a and b, and okay, this is our formula for the projectile. Y is equal to x tan alpha 1 minus x divided by r, where y is the vertical distance and x is a horizontal distance. And the first case, vertical distance y is equal to a, for first case y is equal to a, x is equal to b. Just think, y is equal to a, x is equal to b, then we get from this equation a is equal to b tan alpha 1 minus b divided by r. So b right hand side to left hand side, and this is equation 1. And for the second case, horizontal distance is a, that means x is equal to a, vertical distance y is equal to b, and now y is equal to b and horizontal distance is a. So this is equation number 2 from second case. Okay, now equation 1 dividing by equation 2, then we get, we have to prove this is our horizontal range for the ball. Okay, okay, dividing equation 1, we get from equation 1 divided by 2. Okay, a divided by b, if divide b, we can write by multiplication, then it will be a divided by b, a divided by b, then it will be a divided by b is equal to tan alpha divided by r into 1 by, it will be reversed, so r divided by 10 alpha r minus a. Okay, so a square divided by b square is equal to r minus b divided by r minus a. Okay, we have to prove this, the value of r. Now a square into r minus a, b square into r minus b, then a square r minus a cube is equal to b square r minus b cube. Okay, a square r minus b square r is equal to a cube minus b cube. Okay, so common, r is common, then a square minus b square is equal to, the formula of a cube minus b cube is equal to a minus b into a square plus ab plus b square. Okay, ab plus b square from the both side, then we get r is equal to a square plus ab plus b square divided by a plus b. This is our proved or should. Okay, my dear student, this is our today's class.